We're going to look at learning objective A and evaluate nth roots that are either in exponential or radical form, and we're going to do it without a calculator. So let's just first talk about what nth roots are. If we were given a standard equation, and this is just in a very abstract formula, and if we wanted to get x by itself, the only way to get rid of the little exponent, which is n, would be to multiply by the reciprocal of it. So what you would do here is you'd multiply by 1 over n, and this would become 1 over n. So the equation would say x equals k to the 1/nth power. Well, the 1/nth power can be written as a root. We would call it the nth root of k. So that's kind of the format we're looking at. So I want us to look at these 4 different numbers right here and see if we can talk about evaluating them and what do we get for an answer. What here, letter A, what's the square root of 36? The square root of 36 just means what number 2 times gets me 36? Well, the answer to that is 6. Letter B wants to know what is the square root of negative 25. That again just says what number twice, if I multiply it by itself, gives me negative 25. Well, this one right here is actually not going to be a real number. It ends up being an imaginary number. It does end up being 5i. Letter C, this is the cube root of 27. Cube root means what number 3 times gives us 27, and that one is going to be a 3. And the last one is the cube root of negative 8. So the cube root of negative 8, what number 3 times gives us negative 8? There is such a number, it is negative 2. Now, we just got done evaluating these when they were just the single number by itself. But I want to show you how these are a little bit different if they were written as an equation. And I'm just going to look at letter A, which says the square root of 36. Now, what that would have been if it was written in more of an equation format and just not a numerical answer, they would have written it as x squared equals 36, and then the question would be, what number squared is 36? Now, if I just evaluate the number, there is only one answer for this. But if I solve this equation, be careful, when you solve this equation, you would take a root, the square root. Now, what you do, it would be x equals the square root of 36, which has to be plus or minus, because the answer here could be either plus or minus 6. And that means I could put a 6 in here and square it, but I could a negative 6 in here and square it. Now, what this little diagram down here is showing you is this one thing. If the exponent we're looking at is an even number, so in this case we have a 2, if it was a 4 or a 6, in that case you have to be very cautious. There can be 2 answers. Sometimes there will only be 1, sometimes you'll have imaginaries, but there can be 2, again, if this exponent is even. Now, if it's odd, let's look at what letter C here would look like as an equation. They would have said x cubed equals 27. So to solve it, you'd come in and you'd take the cubed root of that. So then you'd say x is equal to the cubed root of 27. So you want to ask yourself, though, wait a second, here we did plus or minus. Is this a plus or minus also? Well, think about it. What number can you put in here in cube such that you get 27? Is it plus and minus 3? It's not. It can only be a 3 here. So the answer is there's only one answer. So what they're telling you here is if this power or exponent is an odd number, then what you're going to find is it has exactly one real solution. So if you need some tricks to help you remember, should there be one answer, should there be 2, should there be imaginary or no solutions, again, the exponent up here will help you realize there would only be 1 for an odd power, there could be 2 for an even. Okay, so let's look at some of these and start evaluating them. Now notice these 3 examples here, they're not equations, they're just simplify the number. So we're not going to say plus or minus, it just is what it is. And what we're going to talk about is the nth root also means to the exponent of the 1 over n power. So now they want us to evaluate this without a calculator. So this is called a rational exponent. If I wanted to, I could write that as a radical. It means the cube root of 125. It means the same thing. They both basically mean what number 3 times gives me 125. The answer here is 5. Now, this letter B here, I can either keep it as a rational exponent, or this one as a radical, means the square root of 1 over 36. And if I have a square root, I can actually break that radical up like this, and that'll simplify to 1/6. So that's actually going to be our final answer. Now, if you keep it as an exponent, what you can do, remember, this exponent would go to both pieces. So it would be 1 to the 1/2 power, 36 to the 1/2 power. Recognize any exponents that are fractions are roots. So this just means the square root of 1 and the square root of 36, which will give us the same answer. Now, letter C here, they want us to find the 4th root of 16, and be careful, that negative is just out on its own. If the problem had looked like this, that's absolutely different. So what this one actually is a negative sitting out there, and then it's really a 4th root like that. So the question is, what number 4 times gives us 16? This value right here is a 2. But then again, don't forget this negative sitting out there. So the answer is -2. Now, if the original problem really was this would say, what number 4 times gives you -16? There is no such real number that will actually give you that, so this ends up being imaginary. Now let's just take a look at this next example. Here we have the square root of -64. We've already done complex numbers, so we know that the square root of a negative actually becomes an I on the outside. So we're left with 64. The square root of 64 itself is 8, so the answer here is 8I. Because this answer is imaginary, it's also considered a complex number, so this does end up being a complex number.